Alright, now we're going to take a look at page 5, 2c. So you're given here x cubed plus y equals 0. Alright, now here I could draw a picture, but I think what makes this very clear is that this exponent, and the only exponent associated with x, is an odd. Okay, because it's odd, this will probably be an odd function. Now, if you remember from the initial video, we said an odd function is symmetrical with the origin. Okay, so if what I'm saying doesn't make sense, you may want to go back and watch the original video on symmetry. Okay, so I'm going to assume that it's going to be odd. In fact, I'm going to test that it's odd. Now, I want to make one other comment. I didn't make this comment earlier, but I think it's fairly important. It doesn't always have to be that every equation that we write out has to just have one symmetry. So you could be symmetrical, it could be symmetrical with the y-axis, it could be symmetrical with the x-axis, it could be symmetrical with the origin. It could be 2 of them, it could be 3 of them, it could be none of them. All of these are possibilities. Okay, so I'll challenge you real fast to think of an equation that is symmetrical with everything. The x-axis, the y-axis, and the origin. It's pretty easy if you really think about it. An equation that has all of this symmetry is a circle. Okay, I know that does not look like a circle. It looks almost kind of like a pretty weird looking piece of bread. But it is in fact a circle. And if it was in fact a circle, I should say, then what you would notice is that it has symmetry with the y, the x, and the origin. And so a circle is a perfect example of something that has symmetry with everything. Okay. However, in the notes that we're working on, okay, once you find symmetry with x or y or origin or none, you don't have to keep testing. Okay, so if I know this is, like I believe this is going to be symmetrical with the origin, once I run that test and it works, I can stop. I don't have to keep running through every single example. Okay. One other note, and sometimes you'll say I'll say things wrong here, but 99% of the time or 95% of the time I'm pretty accurate. But this is an equation of a circle. It's not really a function. It's not a function because it fails the vertical line test. Okay? Anything that is symmetrical with the x-axis is going to fail the vertical line test. Now that might help you out a little bit, because if you know it's symmetrical with the y-axis, with the x-axis, and the question is asking is it a function, the answer clearly has to be no. So keep that in mind. A little piece of information that's probably going to help down the road. Okay, so what do we do here? Well, to find symmetry with the origin, we make both what? Yeah, x and y negative. So we're going to have negative x cubed plus negative y equals 0. Now, at first glance, let's simplify this a little bit. So obviously when you do negative x cubed, that means you're multiplying a negative times a negative times a negative. So negative times a negative is a positive, times a negative would be a negative. Okay? So this is negative x cubed minus y equals 0. Alright, so you look at that and say, okay, is this the same thing as the original equation? Doesn't look like it. But if you multiply through by negative 1, what's going to happen is you're going to change your signs. Okay, and because it's equal to 0, the equation actually becomes the same. Okay, so one thing you can keep in mind as you work through these problems is that if you're solving these questions and it happens to be that you look at an answer choice, your equation, you're not 100% sure, it's not 100% obvious if it's the exact same as the original, multiply through by negative 1 and see. If it's not, then it's not. If it is, then it is. Okay? Also, when do you know to use this? You see, notice that this is positive and this is negative and this is positive and this is negative. If that happens, then if all your signs are just the opposite of the original, then it actually is going to be symmetrical, because that's what happens when you multiply through by negative 1. It just changes all the signs. So this is symmetrical with the origin. Anything that's odd is always symmetrical with the origin. Hopefully that helped you out. See you in the next video.